You do it for the thrill, the challenge, the escape. To be the boss, to defeat the boss. Whether in space, underwater,
nothing can stop me.
In the past, future, or maybe right here, right now.
Nothing can stop me.
To bring people together to solve what others can't.
Nothing can stop me.
Your game is everywhere, or just beginning.
Nothing can stop me. Nothing can stop me. Nothing can stop me. I'm on fire. Are you feeling the heat? I'm shaking when I'm stomping my feet. Nothing can stop me. Nothing can stop me. I am alive. Nothing can stop me.
A spark, an idea.
Nothing can stop me.
Small or grand, one at a time. You're making a difference. One pixel, one player at a time.
Good morning, everybody. Good morning. Good morning to all of you. My name is Matt, and I'm the new president and CEO of Unity. Whether you're, you don't need to do that, but thank you. Whether you're here today with us in Barcelona or watching us on YouTube and Twitch, we're really happy to have you with us today. Welcome to Unite 2024. I feel so privileged to be here, kicking off a conversation with all of you about the future of Unity. Thank you for making time for us. And a special thanks to all of our sponsors who've been so instrumental in helping us to bring this event to life. Now you're pushing it. During these first few months at Unity, I've been able to connect with many of you from all over the world, from game developer user groups in New York to customer visits in Europe and the Middle East and partner meetings in Silicon Valley. And having Unite come up so soon is a special opportunity for me to come and continue to connect and learn from all of you. Making and playing games has always meant a lot to me. I started out as a kid playing Dungeons & Dragons with my friends, never realizing that I'd be lucky enough to work in this industry for so long. I helped start the first esports league in North America, and I've spent the last 15 years or so working with some of the best games teams in the world, making MOBAs and RPGs, racing games, word and puzzle games, and everything in between, using at least 5 different engines and publishing across every platform. I've also faced the challenge of helping those games find a global audience and build sustainable growth as live services. During most of that time, I've been a customer of Unity's on both the engine and the advertising side, so I understand deeply the power of the Unity ecosystem. But candidly, I've often struggled at times with the direction of the company. The challenges you face as developers are not an abstraction to me, and sitting down to work out how we can see together is why I'm here. I know the heart of this company. We began Unity animated entirely by a passion to change game development forever. We partner with brilliant designers and developers, artists and teachers, engineers and publishers to create the games industry as we know it today. It's a place where games are built by anyone, for everyone. That's an idea we call democratizing game development. And at this point together, we've made that a reality. We provided the tools, and you, our community, rallied around them. The result was a new world of entertainment on a new set of devices, and it skyrocketed. Billions of players, billions of devices, billions of dollars in the industry. But the truth is, we kind of lost our way in the whirlwind of this new world we helped create. Things got a little complicated. We tried to become everything to everyone. The metaverse, the movies, if it had 3D in it, we wanted to power it. And there's nothing wrong with that kind of ambition. Those goals are exciting and they're laudable. But ultimately, we know we're at our best when we're working hard, sitting side by side with game developers like you that we've known for more than 20 years, helping you develop and deliver exceptional entertainment. So we're rededicating ourselves to that mission. I know that growth has been much harder to come by our industry than recent years. We're late in the hardware cycle, there are difficult macroeconomic conditions, and developing games and acquiring new players is more expensive and more challenging than ever. But we can and will innovate our way through this difficult time, and we're going to do it together. It's what our industry has always done. And we want to be a driver of that innovation. We want to provide the tools and technology and expertise to help you build games and acquire users more quickly and more efficiently than ever before. With what we're showing today, we mean to demonstrate just how we're going to play our part to become the partners we once were, only better. We plan to be more focused on things that make a tangible difference to you every day, ensuring that the ecosystem of content creators, educators, and developers that makes Unity unique remains strong and vibrant. We're going to be more focused on stability and performance and support, more capable of helping you through the entire game development lifecycle, from the second you start a new project to that magic moment where your creation meets its players. To put it simply, Unity is here to help you develop great games and to find ways to connect those games with as many players as possible. There's so much exciting work to be done, and we feel privileged to be a part of this with you. But we're here to show you, not just tell you what we're doing. So let's get started. Thanks again.
Wow, those games look phenomenal. And a few of these devs will be joining us here at Unite to tell you how they build them. We have so much to share with you today, so let's just dive right into the good stuff. For nearly a year now, we've been telling you how excited we are to release Unity 6, our next generation release. The Unity 6 preview launched in May and has been adopted quickly. So today, we're going to show you 6 examples of Unity 6 and supporting services in action. We have a cinematic demo of our new real-time graphics features. We got Den of Wolf, the latest game from award-winning developer GTFO creator 10 Chambers. An indie studio, Highrise, that's deploying our complete multiplayer solution to bring their first game, Degenheim, to life. We have Second Dinner's industry-leading mobile game, Marvel Snap, keeping players engaged with live ops services. And we got Cybo using Level Play to monetize their player base in the legendary game Subway Surfers. And we have Stratton Studio, leveraging our support for Web GPU to instantly bring players into their game slice, Project Prismatic. Unity 6 is driven by your feedback. And we focus first and foremost on delivering stability and performance at every step of your creative journey. The Unity 6 preview has shown that our investments in the work are paying off. Overall, crashes are down compared to 2022 LTS. New graphics features are boosting performance enormously. And we're bringing you new capabilities for creation in the editor. Unity 6 includes big improvements and new features for graphics, for creating multiplayer features, and platform reach, as well as advancements in the tools and features you know and love, like dots, our data-oriented approach to coding that unlocks massive performance gains and more control at scale. Unity 6 will be our biggest and most stable release to date, bringing you our best set of tools for building video games yet. So today, I'm extremely excited to announce that it will be available on October 17. And it's backed by learning resources, samples, technical deep dives, and best practice guides, and more to help you hit the ground running this fall. And we plan to support this release well into the next generation of Unity releases. So let's dive in. We'll start with graphics.
Over the last few years, we've invested heavily in our scriptable render pipelines,
which you might know as the high-definition render pipeline, or HDRP, and the universal render pipeline, or URP. And this investment is really starting to show. In 2023, 90% of Unity games released on Steam were made with SRPs, as well as over 50% of mobile and XR games.
on everything from low-end devices to high-end consoles, from stylized 2D to photorealistic graphics, and everything in between. Unity creators are proving that SRPs are performant and flexible enough to help you bring your artistic vision to life. And you can see that at work in all kinds of incredible, groundbreaking games.
Like Scopely's global hit, Monopoly Go. This is the most successful mobile game launch ever, surpassing $3 billion in revenue and attracting 10 million daily players.
Harold Halibut by Slow Bros. A beautifully crafted, stop-motion-inspired graphic adventure with mesmerizing characters and environments on Xbox, PC, and PlayStation.
Racing Kingdom by Super Gears. This offers a fun, ultra-realistic driving game for mobile.
V Rising by Stunlock Studios. A sprawling, open-world vampire RPG that's built with dots and HDRP for play on PC and PlayStation 5.
And Synth Riders by Cluj Interactive. This is an immersive mixed reality rhythm game playable on a range of platforms, including Apple Vision Pro. Of course, these are just a few of the really great games made with scriptable render pipelines. Elaine, what's coming up next for graphics?
Well, we've continued to evolve SRPs in Unity 6. And one new capability is Render Graph. Now, this is a game changer for 2D and 3D mobile developers. This new rendering framework in URP leverages the latest tile-based GPU optimization techniques to significantly lower memory bandwidth by up to 50%, and it also reduces battery usage.
We're also really excited to share more details about the new lighting features we're delivering with Unity 6, like the new light baking architecture, which provides a simplified workflow and robust code base for light baking that's more stable and reliable. Then we have Adaptive Pro volumes, which unlock a range of new capabilities to enhance the visual quality of your projects with more realistic lighting effects. For example, lighting scenarios and sky occlusion can help you achieve interesting lighting transitions like time of day.
Unity 6 also brings new features that maximize CPU and GPU performance. First, with the GPU resident drawer and split graphics jobs, you can render faster. This changes how a scene is sent to the GPU to save CPU processing. GPU occlusion culling boosts game object rendering by automatically reducing the amount of overdraw in each frame to improve GPU performance. And spatial temporal post-processing, or STP. This is our new state-of-the-art upscaler that boosts GPU performance. It takes frames rendered at a lower resolution and upscales them while maintaining fidelity. STP brings consistent, high-quality content across platforms with varying performance and screen levels, from mobile devices to high-end consoles.
And depending on your project, using these features together could reduce CPU and GPU workload by up to 50% while providing smoother and faster rendering, and it works across platforms.
So exciting. Now, in last year's Unite keynote, we shared our Fantasy Kingdom demo for HDRP. We created this stylized environment using Cinti Studios assets to showcase the latest capabilities for rendering, lighting, and performance. And soon, you'll be able to start learning and experimenting with a new version of this demo in Unity 6 for URP. The demo and related assets will be available free for non-commercial use in the Unity Asset Store next month, alongside the release.
And we've optimized the Fantasy Kingdom demo to run on mobile devices. As you can see, I'm running it right now on my phone. This scene contains around 4,000 trees, and there are no technical issues like flickering or lag. They were created with SpeedTree. So we could pack textures and wind into a single lookup to make content load quickly while keeping a consistent frame rate. And SpeedTree's new lightweight wind makes trees run faster with better texture handling on the GPU.
SpeedTree 10 is available now, with more freehand and organic procedural workflow options for greater control, a sleek new interface, and more. And you'll be able to see some of these Unity 6 features in action in our next demo, a peek inside our latest real-time cinematic, Time Ghost.
The project you just saw uses the unmodified Unity 6 engine on a 4090 GPU. Unity 6 brings a lot of improvements across the board, giving us better visual quality, enhanced realism, and improved performance for complex game imagery. For example, in just this one scene, we have multiple animated characters, a detailed environment, tons of VFX with dynamic six-way lighting, volumetrics, clouds, real-time shadows, and millions of blades of grass. So how did we fit all of this into the demo in real time? Let us look at some of the ways in which Unity 6 features helped us.
So first, let's look at the lighting. To get high-quality results, a scene will typically require different lighting setups in different parts of the scene. For example, this trench is a pretty tight space with lots of irregular surfaces for light to bounce off. But over here, we have a wide-open plane where the lighting is more or less uniform. Unity 6 includes the new Adaptive Probe Volumes feature, which automatically places light probes where they're most needed. So when I visualize the probes, you can see that the ones in the trench are much more dense than the ones out on the plane, capturing more detailed changes in the lighting. Scenario blending lets us bake different states of the lighting setups and blend between them. Here, we have separate lighting scenarios for different times of the day in the same environment. Changing the sun angle and ambient color is accomplished through real-time lighting, but the baked lighting scenarios now also allow us to change the indirect lighting to match. Next, let's look at the vegetation, the trees and grass that bring this world to life. There are more than 12 million instances of vegetation in this scene. That's a big challenge for both authoring and rendering. We used Houdini to scatter our trees and grasses, exported their basic properties into Unity as point clouds, and then used that data to create entities in Dot's ECS. Our ECS baking systems produce entities for each piece of vegetation, as well as creating imposters for clusters of vegetation that can be used at distance. So right now, we've streamed in about 8 million pieces of vegetation in the imposters, and another 480,000 as individual entities. So we have nearly 8.5 million pieces of vegetation active, but we're passing fewer than 500,000 entities to the graphics system.
So that is how we brought this world to life. But there is one more thing that we want to talk about in Time Ghost that we think points to some really cool possibilities. Achieving complex deformation for something like detailed cloth movement takes a lot of computing power. So traditionally, we've had to choose between creating at a high level of fidelity or creating in real time. There are already advanced DCC solutions for authoring cloth simulations for pre-rendered offline content, like Marvelous Designer or Houdini. But bringing that level of realism and sophistication into game development has always been a challenge. So, what if we could take a large, complex data set describing cloth movement and turn it into something fast enough to run in real time and small enough to fit in memory? At its heart, this is a compression issue, a space where AI has been used to solve problems for decades. So an artist on our team created a custom AI model to approximate these high-quality deformations, then apply them in real time using Unity Sentis, a package for Unity 6 that lets you bring AI models into the Unity runtime.
To train our own AI model, we used DCC tools to create 2,000 frames of animation to simulate the cloth movement on our high-resolution mesh. This looked great, but the data we'd produced was over 2.5 gigabytes in size. So we processed the data to extract the character's joint orientations and the resulting vertex deformations. Then we used the machine learning framework to train our custom AI model to predict these matching pairs of inputs and outputs. Training the model took about an hour on a desktop PC. And once that was done, we had an AI model that we could run in our project with Sentis to bring high-quality deformations at runtime. And there was only about 50 megabytes on disk. So now our protagonist's full costume deforms in 0.8 milliseconds per frame, and it looks just as good as the high-quality deformations that we computed offline.
If you want to get your hands on this demo, you won't have to wait long. We'll be releasing scenes with the environment and the character using the cloth deformation you just saw. They'll be available alongside Unity 6 next month.
We used a lot of our new tools and features to make Time Ghost because we want to dog food the release and push the limits of this tag. Let's see what other early adopters are doing with it.
Hi, I'm Simon Viklund, one of the co-founders of 10 Chambers. Unfortunately, I can't be with you today because we're working hard on our next delivery for our game, Den of Wolves. However, my dear friend and colleague Svante is there to guide you through a tech demo showing off what we're working on. Our upcoming game, Den of Wolves, is a 4-player co-op first-person shooter heist game set in the future. Our previous game, GTFO, was developed in Unity, and we're sticking to Unity for Den of Wolves as well, but we're upgrading to Unity 6. There are many reasons why we at 10 Chambers love Unity, but I'll tell you a few. First off, we're fans of fast-running, optimized games, and the extensibility and scalability of dots helps us make sure that Den of Wolves runs smooth. Secondly, we like to experiment and try out different gameplay ideas. This is especially true for Den of Wolves, where we're trying to evolve what a heist game can be. Unity 6 lets us iterate quickly and freely, which we love. Thirdly, the new GPU-driven rendering technology and VFX capabilities. Chef's kiss. At 10 Chambers, we like to build a lot of our tools ourselves, but when the team at Unity showed us a scene with our assets in Unity 6, we were blown away. Now to the fun stuff, seeing it all live. Svante Vinternath will walk you through a scene in Den of Wolves to showcase how much control we have over the information sent to the GPU and just how fantastic the game looks in Unity 6. Thank you, and have a great time at Unite.
Thank you for the pre-recorded intro, Simon. I'm joined by Mike from Unity, who will help me out. Yeah, he deserves an applause. Starting out, we intended for Den of Wolves to be made with Unity 2022 LTS. But after seeing the improvements in Unity 6, both in terms of performance and rendering quality, upgrading became an obvious win. Upgrading is always scary, you all know this, but upgrading to Unity 6 was surprisingly easy, especially considering we did it mid-development. We wanted to move as much heavy lifting as possible from the CPU to the GPU and make everything else on the CPU as performant as we could. The first part means Unity 6 HDRP, and the second means dots. Sadly, I can't reveal too much about the game and how we're leveraging dots today. My PR team would kill me. But what I can show you today is how we're using some of the tools from the Unity 6 rendering tech stack to achieve our vision. So, here we have a pre-alpha test scene from the game, which is using Unity HDRP. As we look around, you can see how we're using various lighting elements, structural objects, and decals. We all know that managing draw calls in a game is important, and when we created GTFO, we had our own solution for this. However, the new GPU resident drawer in Unit 6 handles this out of the box.
Now, while turning it on here doesn't seem to affect much, I've just reduced the draw call batches by around 45%. Additionally, this wraps the batch renderer group's low-level API, which is foundational to other important features we'll look at.
Absolutely. Also, while likely getting our hands dirty with low-level API later on in production, in the meantime, it's awesome to just click a checkbox to get a reduction in draw calls during the prototyping stages. One of the major benefits of using the drawer is that it also enables us to use GPU occlusion culling.
Bam.
As you might guess, this feature pushes the occlusion calculations from the CPU to the GPU, which takes advantage of the GPU's ability to handle large amounts of data at the same time. Then there's spatial temporal post-processing, which is a mouthful, but it allows us to upscale from lower resolution to high resolutions performantly with limited loss of fidelity.
And while Den of Wolves targets PC for early access, they do plan to also target console at a later time. Luckily, SDP is hardware agnostic. It works at a range of devices from mobile to console, HDRP and URP, all with a low overhead. Furthermore, supporting DirectX 12 in Unity 6 is a big and important jump for our users.
Indeed, using the new DirectX 12 updates makes multi-threaded operations more efficient, distributing the workload across multiple CPU cores with split graphics jobs for rendering. DX12 also supports advanced tessellation and shading techniques, so we can get even more detailed and realistic graphics. Now, Mike, let's talk about lighting.
Sure. So we believe that ray tracing is absolutely crucial for our users who want to achieve the highest levels of graphical fidelity. That's why we've recently added optimizations such as solid angle culling. DirectX 12 also supports ray tracing-focused hardware, such as NVIDIA's RTX GPUs.
Add to that a more flexible pipeline, and we have the tools we need to create highly realistic lighting, shadows, and reflections that significantly improve the visual quality of the game. We also need a performant global illumination, but manually placing thousands of light probes requires hundreds of hours of work, and this is something we just wouldn't do. I did ask our art director about it, and he said a flat no. Instead, using the new adaptive probe volumes, or as the cool kids call them, APVs, saves us a ton of time.
So as you've already seen today, APVs allow you to place an automatic geometry-driven probe volume that gives you higher quality per pixel lighting in your scene. We've also added some new debugging features. So here, I'm examining the pixels in the scene to see which probes are contributing light values, so I can make adjustments as needed. There are more graphical debugging tools available, and together they make it easier to get things exactly how you want them, while avoiding problems like artifacts and light leaking.
There are many reasons why we choose Unit 6 for DenoVolves, and the cool thing is that they all work together efficiently.
1,000%. So working with the folks from 10 Chambers on this test scene, we were able to achieve both increased visual fidelity and a 23% performance boost so far.
Yeah, it's been awesome to try out these features and seeing them in-game. And we've been partnering closely with engineers from Unity to provide feedback to the R&D teams who are continuously improving the tech stacks. You'll hopefully see them in action soon, and I'll see you in the Den of Wolves.
Mr. Bowman, your reservation at Manon Ekins is in
Cancel the reservation. Reset the procedure.
Continued neuroprodding may severely damage the suspect.
Reset the procedure.
Yes, standing by.
Eject. I'm Mr. Bowman. Your subconscious was just spilling the beans about your recent Akajima district break-in. Let's continue. Huh. What were you hoping to find in the Nexus Sentinels? You mother... There's no use in fighting. I will get what I want. So that's how you found out about our Akajima vault. What were you looking for? A key. A key to what? You really know? Yes! What's the key for?
It's not what, Mr. Bowman. It's who. You see, just like me, you're caught here. You're caught in the Den of Wolves.
Part of the magic of video games is how they connect us. Whether we're on the same couch or different continents, playing games together can help us build friendships or feuds, lifelong bonds or fleeting alliances. Every year, more of you are building multiplayer games. And it's clear why. Players absolutely love them. And they can offer great retention, engagement, and revenue opportunities. But multiplayer features add a lot of complexity. So today, I'm going to talk about what we're doing to streamline building, launching, and scaling multiplayer games with the Unity engine and pre-integrated multiplayer services. We all know different genres have different requirements. So even seasoned devs often need to rethink their tech stack for each title. Plus, ideas evolve a lot during concept and pre-production phases, which means you might need to experiment with a variety of solutions quickly so you can nail your prototype faster. That's why we created Multiplayer Center. It guides you through the solutions landscape for multiplayer game development, recommending the best tools and services for your project vision. Hryb here is going to show you the tool in Unity. Now, here's how the Multiplayer Center would help you add a multiplayer experience to our new prototype. First, we need to select a genre. Let's try and make something like Mega City Metro, our massive player scale sample. So in this case, we'll select the shooter genre. We're going to set the number of players fairly high. We'll go with 128. In this case, Multiplayer Center recommends using netcode for entities, our DOTS networking solution, which comes with additional packages and dependencies like ECS for Unity that you can add to your project with a single click. And this is all backed by inline documentation, samples, and other resources curated for you based on your gameplay specifications. Now, we've already brought these packages down, so we'll click through to the quick start. Here, we can create a basic scene with netcode already set up. We can explore some workflow and network tooling, and even start to add some online functionality. Speaking of, the new Multiplayer Services package further simplifies your workflow, giving you access to a complete set of APIs and tools to integrate online multiplayer features into the game. Through widgets, you can add relay, lobby browsing, quick join, join codes, and Vivox voice and text chat capabilities to your scene and start experimenting in seconds. Using this workflow, Hryb has gone ahead and dropped in a complete, styled multiplayer widget scaffolding along with some Megacity assets so we can get up and running to try out an idea quickly. Okay, Hryb, could you also add text chat to the project? Let's see how fast we can do it. All right, we found the text chat widget in the Create menu, and it's dropped into the scene. Hryb will find a spot for it that makes sense in our UI and apply some styling to the UI elements to match the rest. We'll save the scene, and Hryb has already beat me to click play. Now, this will spin up two game clients with the menu we just made. On the right, we'll create a session with the quick join button. On the left, we'll browse and join that session. We even start to see our networked objects begin to spawn in. We have a lovely hovering ship. Now that they're both joined, our text chat is connecting up, and we can send our first message. All right, we just added text chat to the scene. Now, all of the UI you're seeing on screen, these are also widgets, added the same way in about the same amount of time. And just like you saw, you can customize them to fit in with your own game UI. Now, we know that setting up your tech stack is just the start. Playtesting, simulating, and hosting test environments is challenging and time-consuming, but critical. With the new multiplayer play mode, you can simulate and test multiplayer scenarios right in the Unity editor. Hryb is showing us this here in Mega City Metro. Now, we want to run multiple instances of the game side by side so we can test out our ship combat. We simply check how many players we want, and then 3 separate live windows spin up next to the editor, each running a client of the game already wired up together. Moving our ship on one side, moves it on the other. So because it's integrated in the editor, this means speedier iterations, immediate feedback, and less switching between tools. So we hope this accelerates your playtesting significantly. We updated Mega City Metro for Unity 6, so you can download it now to start exploring these features. Of course, the challenges don't end once your game is built, or even after it's launched. It's impossible to predict how popular a new title will be. So while it's tempting to start with a client hosting solution to limit costs and risks, a client hosting solution can put you at the mercy of host disconnection, bad latency, and limited performance. This is why we're offering a new network topology called distributed authority. It's a backend solution that keeps the state of the gameplay server-side, while the simulation is distributed to your players' game clients, solving seamless host migration and helping you achieve cost-effective, engaging multiplayer experiences. And once you've nailed your player experience and locked in some funding, if your design needs it, our tooling can also help you grow into a dedicated hosting solution. I hope you're excited about what you've seen here today. We're investing deeply to expand and evolve our support for multiplayer services with closer editor integration and more learning resources to help you get started. We're removing as many hurdles as we can to simplify the work of creating and running complex games while making it easier for you to bring your players together at every stage of your game. Up next, please welcome Milan Preshow from Highrise Studios. He's going to tell you why the small team of industry veterans went all in on multiplayer services and tools for Degenheim.
Hello, everyone. So great to be here at Unite. First, a short introduction. We're a small, self-funded indie studio of roughly 20 people, based mostly in Slovakia. We're new, but not inexperienced, with well over a decade in gaming, working for big names such as EA, Lego, Fingersoft, Nimblebit, and more. Well, while we spent years growing games of others, we really craved creating something which would be truly our own, which leads us to our first game, Degenheim. It's an action-packed, top-down hack-and-slash roguelike, which you can play a bunch of different ways, whether it's alone or co-op with your friends, with big brawl chaos in all directions. We all know what game devs love and what they hate. They love building games, but when it comes to architecture, building the backbone and servers, they despise it from the bottom of their hearts. At first, we tried multiple solutions, third-party asset packs, somehow tried to glue it together into a functional game, and, well, you guessed it, resulted mostly in a lot of stress, a lot of frustration, wasted time, and money. And at the end of the day, we actually ended up throwing it all out of the window, but we're lucky enough to be able to replace it with a Unity suite of services, which allowed us to easily integrate a whole ecosystem into our game, which is already pre-integrated into Unity 6, namely netcode for game objects, which we use as a solution for the whole networking and dedicated servers. Multiplayer server hosting, which is by far our developers' favorite because it spins up the instances of servers for our multiplayer instead of us having to do it on our own. Then there's Cloud Save that stores the progress of all our players, and authentication, which we use for integrating our game into online points of sale and other platforms easily and effortlessly. We also use remote config. It allows us to do seamless balancing and updates of the game without ever having to push a new build out every single time. On top of all of that, we watch over everything closely using Unity Analytics, Cloud Diagnostics, Event Manager, and SQL Data Explorer. These tools give our game designers an easy, accessible, and reliable overview of everything that happens in our game. And the best part is, it's all under one roof. No clunky, semi-functional, glued-together abomination of countless third-party options. It's all pre-integrated and ready to go. As an indie studio, this was a huge game changer for us. It allowed us for experiencing the big studio possibilities, abstracting away the complexity which devs hate, and allowing us to focus on what we love, the game itself. Stay tuned for Degenheim, coming into early access on Steam this fall. Thank you.
In a hyper-competitive mobile landscape, extending live games' lifespans is essential. But keeping players interested is tough. To drive engagement and retention, you have to understand your players. You need to release high-quality content at a breakneck pace, while also managing costs and maintaining stability. Unity Live Ops services help you build your game, manage your releases, and understand the impact and performance of changes in your live game. Some of the biggest games on mobile use these tools to keep their content fresh and their player base active, like the massive free-to-play hit Marvel Snap. The team is constantly rekindling players' excitement with new card variant drops, weekly missions, monthly themed battle passes, and more. Second Dinner launches a new season of Marvel Snap every month with new cards and gameplay mechanics. And the process is surprisingly simple. Engineers pull a deployment branch from GitHub, create a build with build automation, review and optimize, then push the update live via cloud content delivery. Big games stay big when they keep their players coming back by constantly refreshing their content. And we want to unlock that kind of success in your game. So we've adapted some popular features to make them easier to access across live game services for any studio, from mobile giants to small indies, like Shallot Games, the team behind Coffee Golf. And this support starts with releases. That's a workflow we pulled out of cloud content delivery that simplifies your end-to-end release and content pipeline. Releases will soon be in open beta, and it lets you manage changes across multiple services in one place. Let's see what that looks like in practice if I want to release a new level. It starts with a new component called a release pointer. This lets you have content in your production environment that's not available to real players, so you have control over when and what content is exposed. And this lets you de-risk your entire release management pipeline. So say I use this release pointer to make my level live and available to real players in my target regions. I keep tabs on how it's going with cloud diagnostics, which gives me issues into latency, errors, crashes, API calls, and soon, ANRs. If I detect an issue, I can use the release pointer again to instantly roll back to my previous working release while maintaining backwards compatibility for old versions of my game. This would have taken several complicated manual release workflows before. Then, I can keep using analytics to monitor player engagement, understand the release's impact, and track its effectiveness against my KPIs. Taken together, this feature set gives you a dramatically streamlined release workflow, accessible game telemetry, and powerful analytics, so you can now safely experiment in your live game. Up next, please welcome Google's Jack Buser, who's going to tell you how Google Cloud is changing the game, literally.
You've already heard quite a bit today about how important it is to refresh your game and help it grow. And the numbers back this up. The top grossing games on mobile and PC today are live service games, and consoles not far behind. Building a game is just one chapter of a much longer story. Today, a game's not just something you create and then launch. Your games need to be maintained. They need to sustain players' interest, which is why we're turning our attention to what we call living games. Live games that use AI to grow and adapt to become even more successful. Google Cloud helps you build, deploy, and manage applications on our scalable infrastructure to power exceptional gaming experiences by bringing together performance and insights with critically important game servers, databases, and analytics. Fast, performant infrastructure for game servers deliver incredible experiences to players, while databases remember their past achievements and in-game actions for a more tailored experience. And finally, analytics give you a better understanding of how players are using and interacting with your games, so you can improve how you engage them. Together, these solutions make Google Cloud a powerful, flexible, and secure platform for your live service games, so you can focus on creating art, stories, and mechanics your players will love. Now, all this sounds great. These are some of the most important foundations of a solid live game. But where does the living games part come in? You can see this evolution happening already. We've seen the first phase of box games, where devs create content for players to consume, a fairly one-way relationship. Next came live games, which still make up most games today. Here, there's a cycle between developers and gamers, where players' actions inform how developers update and extend their games with new content. Now, we predict that AI's ability to accelerate development and transform the player experience will power a revolution in games. The combination of live service games and generative AI will usher in a new frontier of experiences that felt far beyond our reach not so long ago. These are living games. In this model, the cycle expands to include the game itself, to enrich the player experience and business outcomes. The developer's vision, players' engagement, and game growth all fuel one another, with AI helping to power it all. At Google Cloud, we see that generative AI is often first adopted as a tool to accelerate work. So studios will be able to scale output and produce more content with less crunch. This can happen in a couple different ways. For example, teams are generating new ideas for new plot points or levels using Google Cloud's Vertex AI, enabling them to iterate more quickly on game elements players will love. Or developers harnessing Gemini to debug and write code faster. And the most advanced developers are deploying generative AI in their games during runtime, powering entirely new player experiences never seen before, and fully realizing the promise of living games. Backed by performance, player insights, and databases, these Gen AI features are another powerful tool in your developer tool belt. One that will help you create the next generation of truly living games. Thank you, Unite.
Unity grew out of a desire to make game development tools available to anyone with an idea. And today, we're committed to helping you grow your ideas into thriving businesses. We have invested deeply in tools to help mobile studios of all sizes reach their full revenue and player growth potential, so they can achieve the kind of sustainable, long-term success that can keep a game thriving for more than a decade. Take Sizzle Games, for example. We're celebrating 12 years of Subway Surfers. With over 4 billion downloads, Subway Surfers has become one of the most recognized mobile games worldwide. And Unity has been proud to partner in their incredible growth for the last 6 years. Using Unity Level Play and its full suite of tools, Sizzle was able to implement ad monetization in a way that drives revenue while preserving an amazing user experience. With advanced real-time reporting, together with robust segmentation tools, Sizzle was able to find the perfect balance in their ad monetization, generating revenue while keeping millions of players coming back for years. We want to make this kind of success possible for studios of any size by making it easier than ever to get started with monetization in Unity. So we've integrated Unity Level Play tooling directly into the editor. We've also simplified the user experience and updated the interface to reflect Unity's overall look and feel, providing a seamless flow from game creation all the way to growth. Level Play in the editor gives you access not just to Unity ads and Iron Source ads, but to 25 different ad networks, all competing to pay the best price for space inside your game. You can also tap into a suite of tools to fine-tune your ad experience, to boost retention and extend player engagement. You get more control over how you execute your monetization strategy with tools and insights into ad quality, visibility into churn, testing ad variance, and segmentation. You can really understand what resonates with your audience, and more critically, what doesn't. You can review ads from your player's perspective, access detailed real-time performance reports, experiment with different formats in A/B tests, and then use all of these insights to build a segmented ad experience tailored to specific player groups. Indie devs in particular are harnessing this technology to turbocharge growth. Since integrating, we've seen almost 90% of Level Play package downloads coming from smaller studios. And we know today's mobile market is extremely competitive. There are currently over 240,000 games on iOS and more than 270,000 on Google Play. So organic discovery alone isn't enough to get your game noticed. And that's why we also have tools to help you with player acquisition. It's easy for you to set up on your own, and you can even transfer your monetization revenue to fund your campaigns. Plus, we've significantly upgraded our AI, helping you engage more high-value players so that every marketing dollar you spend pays off. If you want to learn more about how to make and maximize your first dollar with Unity, check out the sessions in the Grow Your Success breakout track here at Unite. We want to give you the tools you need to succeed in mobile, and whether that's boosting retention and engagement by making it easier to experiment with your live games, or finding new ways to increase your revenue streams with targeted ads. Up next, let's dive a little deeper into the platforms Unity supports.
Hey everyone. We've always been really proud that you can use Unity to bring your games to over 20 platforms across desktop, mobile, consoles, and XR. And we continue to invest in bringing new platforms through our partners across the industry at Apple, Meta, Google, Xbox, Nintendo, and many, many more, so that you have the tools and features you need to take your game anywhere you want, even on day one. And now, with Unity Web, we've been investing heavily into our web platform support to give you more flexibility in how you reach some of those screens. We've added features and optimizations for browsers across desktop and now mobile. And it's a tremendous opportunity. 68% of gamers play on smartphones, and advances in mobile devices and network infrastructure have changed the landscape for browsers on small screens. This makes them not just more effective for running games, but also a popular new platform for casual gamers who are used to consuming bite-sized content online and want to jump in and out of games just as quick. Like you see here with Squad Blast by Ultra Horse. With Unity 6, we've optimized our web platform support to reduce load times specifically for mobile browsers, and leverages advances in WebAssembly to increase performance on both Safari on iOS and Google Chrome on Android. And for added flexibility, you can embed your games in a web view or use our progressive web app template to make your game behave more like a native app with its own shortcut. And this makes it ideal, not just for full games, but also for vertical slices, press builds, or demos, so that you can give players a chance to quickly sample your full multi-platform game without the hassle of downloading or installing a demo file. And speaking of demos, we've got a great one to share with you. Stratton Studios' latest project gives us a taste of the future of web graphics. They've used early access to the web GPU backend in Unity 6 to create this spectacular browser-based FPS sample called Project Prismatic. Let's check it out. Yeah, right? That was awesome. And we've been working closely with the Chrome team at Google to stress test Web GPU with large screens and complex shaders, which has led to some of the fantastic results you see here that showcase what's possible for the future of browser-based gaming. Now, early access to the Web GPU backend is enabled today on Google Chrome and Microsoft Edge on macOS, Windows, and select Android phones. We've made these investments into our web platform support because we know you're looking for more ways to reach a wider audience and get players playing as fast as possible, bypassing any installation processes that could slow things down. And of course, we also want to get your games out there. And that's why we're working with Crazy Games, one of the leading platforms for web gaming. I'm going to announce the Crazy Web Game Jam. And in this game jam, you'll leverage all the power of Unity 6's web runtime support to create a game just for web browsers. And you'll even have a chance to win a Crazy Games publishing deal. And we'll be announcing the game jam theme to kick off development in November. But in the meantime, we'll be sharing web development tips, tricks, best practices, and exclusive goodies like asset store bundles and more just for jammers. And we think web offers a tremendous opportunity. And we want to make sure that you have what you need to take full advantage, while of course still supporting all the other platforms where players love to find your games. Thank you.
The Unity 6 release is the absolute best version of the Unity engine. And now you've seen some of the new features and examples of what you can do with them. So, what's next? We're already rolling additions to the solid foundation of Unity 6 into an update, which we've slated for early 2025. And we're calling the Unity 6.1 update. We'll make it easy to bring your Unity 6 projects to the update when it ships next year. And all of these enhancements are built on the core capabilities that we are shipping with Unity 6. We've been hearing about them today: graphics, multiplayer services, and platform support. We are extending and adding even more value to these key areas. And we're going to be supporting this release for a long time. You can look forward to features like support for foldable and larger screen formats, deferred plus rendering in GPU resident drawer, and new build targets for Facebook Instant Games, and a new build profile for MetaQuest. But while we're already working on the next generation after Unity 6, in fact, we're already over a year into development, and we're really excited about what the new capabilities are going to bring you. We're a ways out yet, but today, we want to give you just a taste of where things are headed and what that will help you to do. Our vision for this release is driven by your feedback. We hear that you need a simpler experience with improved tooling for rendering and better iteration speed, and the power to build games of ambitious scale. You tell us that there are too many systems to choose between, and this adds risk and uncertainty to your project planning, since you have to choose a UI system, a rendering pipeline. We want to remove this complication. To solve these pain points, we're planning a new release generation that marks a fundamental shift in our thinking and approach. It will dig deep into our core and bring you greater speed and simplicity across systems. DOTS is an integral part of our efforts to streamline and improve performance across the Unity engine. So we're bringing ECS the entities component system, into the very heart of the Unity engine. And we're integrating entities with game objects. This shift will bring tremendous benefits, even to those of you who don't typically pick up Dot's features to use in your projects. It will accrue performance gains, even in game objects-based design, as well as hugely increasing the accessibility of entities so that you can tap into that power and scale at any skill level. The content pipeline is moving to a new approach that emphasizes iteration time, taking many import tasks and running them in the background while you're working, which means that you'll spend less time waiting and more time working on projects. And beyond this, we are creating a new world-building system built on top of Dots. So you can create large, detailed worlds across platforms, including an overhaul to the end-to-end workflow, virtual texturing and advanced tessellation to maximize details, non-destructive workflows for greater flexibility, and shader graph integration for terrain surface, the ability to seamlessly blend in meshes. We're also introducing an all-new animation system that offers tools and workflows that are designed for a new generation of games, including production flexibility, animation at scale, and performance across platforms. Now, we also know that scripting is one of the most important parts of your creation experience. So we have been working on moving all mono functionality to core CLR. This will keep you up to date with the latest .NET advancements, and it will bring big performance gains, both to the editor and to the runtime. So, I think you can see why we're already so excited about this big release, even though it's a ways off. And we will continue to support and enhance Unity 6 so that your projects can stay on track. And you can make the jump whenever the time is right, so you can start taking advantage of these benefits. Now, last thing, we want to get this right. So we've started sharing and pressure testing the next major release with a few developers. We're actively soliciting feedback to ensure that what we are building will truly make an impact on how you use Unity every day. Next year, we plan to open up wider feedback through an open beta. We'll have a lot more to share about the future of the Unity engine at our roadmap session here at Unite. So, with that, I'll pass things back to Larry, or should I say, Major Nelson, to take us home.
Thank you, Ryan, and thank you for that sneak preview of what's in store. And that's on top of the new Unity 6 features we saw in action here today. Tons of new and improved graphic and lighting tools, simplified end-to-end multiplayer development, a more robust arsenal for live games, investments in all platforms, including rich mobile web experiences, web GPU, and more, and richer tools to understand and monetize mobile players. Now, it's been a lot to cover in about an hour, so be sure to check out our amazing expert-led breakout sessions to see the tools covered today in the keynote in greater depth, including the latest on 2D and 3D graphics and tools, Dots, our data-oriented design pattern for more performant, flexible game development, much, much more. Plus, don't forget to vote for the 16th Annual Unity Awards. Grab this QR code right now and support your favorites. And stay tuned for those awards on October 23rd. On behalf of everyone at Unity, we are excited to bring you Unity 6 this October. We can't wait to see what you create. Enjoy the sessions. Thank you, everyone.
Bye.